Hello and welcome to Station 7. This is where we're going to review quadrilaterals and their special properties. I believe this is Module 5. If you need extra help, there is a poster on the wall. There's actually two of them. One showing parallelograms and the other one showing other quadrilaterals that are special, but they're not parallelograms because they don't have two sets of parallel sides. All right. Well, the first thing you have to know about a quadrilateral is that the angles add up to 360 degrees, which is different than a triangle. So every time you add on a side, you're adding on 180. All right, so let's go ahead and take a look at number one. So we know that all three of these angles are going to add up and then subtract that from 360, and that'll give you this missing angle here. So if you do 105 plus 75 plus 70 plus question mark, you should get 360. And so to get that, you just add it up, subtract, and you get 110. So that's a quick refresher on how to do this. You're going to do numbers 2, 3, and 4 exactly the same way. Except, if you'll notice, numbers 3 and 4 have variables. But you should have no problems with this. All right, second type of question we can ask you about quadrilaterals is that you have to state the most specific name for each figure. So if I'm looking at, for example, number 5, I'm going to look and I'm going to see, oh, look, the sides across from each other, so like this side and this side, they're not parallel to each other. So I know it's not going to be a parallelogram. So my choice is either a kite or a trapezoid. And if I look, this meets the description of a kite where the sides, corresponding sides are congruent. So that would mean this side is congruent to this side and so on. So this would be a kite. And then to clarify for number 6, I've noticed that these sides are marked parallel. So I'm going to be looking for this one at a parallelogram because we don't know anything about the angles at this point. We don't know if they're 90 degrees or not. And they did not tell us that the sides are congruent. Therefore, I can't assume that it's a rhombus. So the best I can say at this point is a parallelogram. Okay. The next problem I'd like to do with you is number 13. So go ahead and scroll to number 13. And in this case, we know these are parallelograms, but we want to use the properties of parallelograms to figure out what the missing measure is. And so if I look at this, I can see that this is 112, and this one is 12x minus 8. And I know that if they're opposite each other like this, they're going to be equal. If they're next to each other, they're going to add up to 180 degrees. So I'm going to set 112 equal to 12x minus 8, and then just solve this equation. So I'm going to add 8, and I get 120 equals 12x. When I divide by 12, you get 10 equals x. And I look back, and all it's asking me for is x, so I don't have to worry about that. For numbers 17 and 18, I just wanted you to note that this angle right here is 3x plus 2. It's kind of difficult to see. And then 52 is right here. This angle is 52 degrees. I tried to mark it on your paper as well. All right. Again, if they're next to each other, they're equal. If they're if they're next to each other, they add up to 180. Like this one here, they're going to add up to 180. If they're across from each other, they're going to be congruent. Let's go down to number 21. And this was just a special formula. This is the formula here. If you want to find the median in a trapezoid, it has to be a regular trapezoid that is also an isosceles, which means the sides are congruent. You basically just take 1/2 the base, which in this case is 62, plus the top, which is 24. And so 62 plus 24 is what? 86. Divide that by 2, and you should get 43. All right. Good luck on station quadrilaterals. This is station 7. If you need extra help, again, you can look up quadrilaterals on Google. You can look at your resources, and there are those posters that have all the properties of quadrilaterals as well.